Assalamu alaikum everyone. Welcome to this class of coordinate geometry. The second part that is about equation of a circle. It has to do with circle, it has to do with the line. Now what exactly is written in the syllabus? Now the syllabus coordinate geometry, we are interested in point 3 and point 4 and a little bit of point 5. Now what exactly is this? Understand that the equation represents the equation of a circle. Center is AB, radius is R. Now this format is the completed square form of the equation of a circle. And if it's given in the expanded form, we will convert it into the completed square form. It further says, use algebraic methods to solve problems involving lines and circle. It could be related to simultaneous equations. It could be related to property of circle, something like line is tangent to the radius is tangent to the line perpendicular, something like that. Or it could be, there it is, tangent perpendicular to radius, angle in a semicircle, symmetry, let me write more, chord property, and so on. Now, implicit differentiation, that is not included because implicit is not part of P1. And then it says, understand the relationship between a graph and its associated algebraic equation. Use the relationship between points of intersection of graphs and its equation as something to do with discriminant. B squared minus 4AC could be positive, it could be 0, it could be negative, and so on. So everything that you have studied in quadratics, that is applicable over here. So circle equation, this is about coordinate geometry and this is about quadratics. We have already gone over quadratics. Now let's look at the first question, look at it very closely and then I'll get started. I want you to think, read, and then I'll get started with this. I'll just highlight things for myself. Okay, now whatever I have highlighted, let me first get started with that. Now it says a diameter of a circle C1 has endpoints such and such. This is circle C1. There is another circle C2. First of all, we are talking about C1. The diameter has endpoints -3, -5, and 7, 3. So let's say this is -3, -5, this is 7, 3. This is just a rough diagram. So now if I get started with this, so we have the point which is the first one is -3, -5, and let me use the coordinates A and B. So let's say this is A, -3, -5, and this is the coordinate B, which is 7 and 3. That means I need to find the midpoint in order to find the equation of a circle. Because now what is the property? The property is, if the circle is like this, then the midpoint of these two will be the center of the circle. So M, that is -3 plus 7 divided by 2. And this is -5 plus 3 divided by 2. That is 4 over 2, which is 2. And the next one is -2 over 2, which is -1. That is M, which is the center of the circle. What is the name of the circle? C1. So this is part A. Then we are interested in the radius. So the radius of circle C1, that is either AM magnitude or this is MB magnitude. So if I take M and the coordinates of M is 2, -1, and let me take B, which is 7, 3. And let me find the magnitude of MB. That is 2 minus 7 whole square. This is -1 minus 3 whole square, square root. That is negative 5 square, which is 25, negative 4 square, which is 16 square root, and this comes out to be square root of 41 units. That is the radius. So now R is root 41 units. So I have the center, which is 2, negative 1. So center is 2, comma, negative 1. Radius is root 41. I'm still on the first part, that is for 3 marks. And the equation is x minus h whole square, y minus k whole square is equals to r square. So therefore we have x minus 2 whole square, y minus minus 1, which is y plus 1 whole square, and square of root r, square of r, that is square of root 41, that comes out to be 41. So this is the equation of the circle, that is the first part. So the first part is all good, all done. Just acknowledge it on the WhatsApp if it's all good, all clear. So now let's get started with the second part. Let me add a page to it. I think we might be needing 2 sessions for this particular topic. So now the first thing is done. So let me just pinpoint over here. Part A, the center M is 2 and negative 1, radius is root 41. Now I am interested in the next part, that is the circle C1 is translated by 8, 4 to give circle C2 as shown in the diagram. Find the equation of circle C2. Now we know that if we do the process of translation, the transformation that is known as translation, the area does not change. So the area of the figure does not change. So let me just write it like this. Area of figure does not change. That means the radius will still be root 41. So what will change? The center. That means the old center was 2 and negative 1. We are adding 8, 4 to it. And now what should we get? We should be getting the new center. So the new center is 2 plus 8 is 10, minus 1 plus 4 is 3. So this is the center of our circle C2. And then it's back to the same basic, x minus h whole square. This is y minus k whole square is equals to r square. So root 41 square becomes 41. This is x minus 10 whole square, and this is y minus 3 whole square. So now this is the answer for the second part. Part B is done. Now it says the two circles intersect at point R and S. Show that the equation of the line RS is this thing. Now over here, the first is this one. This is M, the center of the circle, which is 2 minus 1. And let me write this thing as N. So this is N 10, 3. So this is N, which is 10, 3. Now it so happens that this becomes the perpendicular bisector. So let me just join these two like this. Let me change the marker. So that is this one, actually this. And this RS is the perpendicular bisector. So RS is going like this. So it is like this. Let me just draw it more properly. Okay. So now this is the perpendicular bisector of this line. When two circles intersect, if we join the centers, then the perpendicular bisector will be like this. This concept is used in loci. So now we have M, which is 2, negative 1. So I'm working for part C. M is 2, negative 1. N, the center of the other circle, is 10, 3. The midpoint, let's call it, what do we have? We have R, we have S, we have M, we have N, we have A, B, let me call it Q. Q, that is 2 plus 10 divided by 2, minus 1 plus 3 divided by 2, that is 12 over 2, which is 6, 2 over 2, which is 1, this is Q. And gradient of Mn, this is Mn, is minus 1 minus 3 over 2 minus 10, which is minus 4 over negative 8, which comes out to be positive half, which makes sense. Yes, the gradient looks positive. Therefore, the gradient of the perpendicular. So now we are talking about this thing. So the gradient of the perpendicular, which is Rs. So somewhere here is R, somewhere here is S. So the gradient of Rs should be negative reciprocal of gradient of Mn, which comes out to be negative 2. And it's passing through Q. So now Q is 6, 1, y minus y1 is equals to negative 2x minus 6, y minus y1 is negative 2x plus 12, y is equals to negative 2x plus 13. Is that the answer? Yes, that is the answer. So again, emphasize on this fact that if two circles are intersecting, this line through the point of intersection will be the perpendicular bisector of the line joining the centers. So now this thing is done. Let's move to the next part. Let me add a page. Let me once again paste this thing. Let me just erase this thing. So now this is all done. We are on the very last part. That is, hence show that the x coordinate of R and S satisfies this equation. So this is equation of line RS. It says hence, that means use part C and either solve it simultaneously with equation of C1 or solve it simultaneously with equation of C2. And we don't have to solve it, just expand and simplify. When we expand and simplify, we should be getting this equation. So now let me write it down. So we have Rs, y is equals to negative 2x plus 13. And let me go back up and either use this equation, that is perfect, or use this equation, doesn't make a difference. I'll just choose the one with small numbers. I'll choose this one. X minus 2 whole square, y plus 1 whole square is 41. X minus 2 whole square, y plus 1 whole square is equals to 41. This is circle C1 equation. Now just expand, simplify, you should get this. So therefore, I'll write x minus 2 whole square. Instead of y, I'll write minus 2x plus 13. That is equation of Rs like this. And this is in place of y, and then plus 1. And then plus 1 whole square is 41. So now I need to simplify this. This is x minus 2 whole square. Let me just work as much as possible. Minus 2x plus 14 whole square is equals to 41. And then let's expand. X square minus 4x plus 4. That's the first bracket. And then minus 2x whole square, that is 4x square. And 2 into 14 is 28, and that is 56. So this is negative 56x, and this is 196 minus 41 equals to 0. So let's get started. What do we have? We have x square, we have 4x square, that is 5x square. We have negative 4x, we have negative 56x, that is negative 60x. And then last but not the least, we have 4. We have 196, which is 200. 200 minus 41, that's 159. So this is 159 equals to 0, and that is exactly the equation that we get. So that is how this first question is done and dusted. All good, all clear? Okay. So now I have not pasted the answer as yet, but the answer was already over there. Now this particular question, I would like you to just go through it and read it, and then I'll get started with this. Okay, now let's get started. Let me also paste it on the next page. And I think 2 pages is enough. Now let's get started with the first thing. The question says the equation of a circle with center C is this much. Find the radius and the coordinates of C. C is the center. So let's focus on this one first. Starting with the black marker, x square negative 8x plus y square plus 4y is equals to 5. That is the first step. Step 1, that is write x with x, write y with y, constant on right hand side. The next step is about completing square method. Step 2, first add, then subtract, and all that thing, square of half the coefficient of x and all these things. So therefore we have x square minus 8x plus bracket square minus bracket square, and then we have y square plus 4y plus bracket square minus bracket square is equals to 5. What goes inside the bracket? Half the coefficient of x, which is negative 4, which is negative 4. Half the coefficient of y, which is positive 2, which is positive 2. Then we are moving to the third part, step 3. That is rewrite first 3 terms as a perfect square algebraic expression. And transfer constants to the right hand side. So now what do we have? Let me highlight it. So now we will take these 3 terms. That's 1, 2, 3, 1, 2, 3. That is the first 3 terms. So therefore I'll have something like this. I'll have something like this, and then let's see how it goes. So this is x minus 4 whole square. I can make it smaller. This is too big. Let me choose this standard eraser. Let me make it smaller. This is x minus 4 whole square. And then this negative 16 is there. That is this one. And then let me use the same color marker again. And this becomes what? That is x plus 2 whole square. And then we have negative 4. That is this one. And then it equals to 5. That is how this step is done. So x minus 4 whole square plus, actually this is, the next one is not x, that is y, my bad. Okay. So this is, let me just erase this. Okay. This is y plus 2 whole square. Okay. And this is y plus 2 whole square, negative 16, negative 4, negative 20 taken to the other side, that is 5 plus 20. So therefore x minus 4 whole square, y plus 2 whole square is equals to 5 square. Compare it with x minus h whole square, y minus k whole square is equals to r square. H is 4, k is negative 2, r is positive 5 because that's the thing. So therefore 4 comma negative 2, that is the center, and the radius is 5 units. All good, all clear? Just have a good look. So now in this question, the very first thing that we have learned, that is the process of completing the square. We have seen it for quadratics. Now we have seen the same knowledge of quadratics applied to equation of circle. I hope it's all good, all clear. Now let's move on. Now it says, let me change the color. So now it says this orange color, the point lie on the circle. The point P, 1, 2 lie on the circle. Show that the equation of the tangent to the circle at P is this much. That is the second part. Now, let me just draw a small diagram to illustrate this idea. Let's say this is a circle. And let's say this is the tangent going like this. This is just a rough diagram. So over here, we have the center. What is the coordinate of the center? C, that is 4 minus 2. So this is C, 4 minus 2. So let me just put it properly. So over here is C, and C is 4 minus 2. And this tangent is at 1, 2. So 1, 2 should be something over here, like this. 4 minus 2 and 1, 2 should be something like this. Okay. So now somewhere here is the tangent. This is P, 1, 2. In order to find the equation of this tangent, what do? We draw a line connecting the center with the point on tangent. This is on tangent. So find the gradient of PC. So P is 1, 2, C is 4, negative 2. So therefore 2 minus 2 divided by 1 minus 4. This is positive 4, this is negative 3. Gradient of tangent should be negative reciprocal because it's perpendicular. So that is negative 1 over gradient of PC, the perpendicular property, that comes out to be plus 3/4. And it's passing through P, which is 1, 2. Therefore, the equation is y minus y1 is equals to mx minus x1. Y minus 2 is equals to 3/4 x minus 1. Do I need to expand it? Yes, I need to simplify. 4y minus 8, 3x minus 3. 4y is equals to 3x minus 3 plus 8, that is plus 5. That is all good, all clear. Part B is done and dusted. So this is part B that we worked on. So now all these working, I'm not using a calculator. I'm not even touching a calculator, but it's very basic, but your concepts should be crystal clear. Let's paste it once more. I need some more space. Now we are on the third part, and that is about this. The point Q also lies on the circle and PQ is parallel to x-axis. What does it mean? We will just soon see. Write down the coordinates of Q. Now, first of all, if a line is parallel to x-axis, yes, we know the gradient is 0, but why does it happen? It happens because the y coordinate does not change. Now, first of all, we have the coordinates of P, which is 1, 2. And Q also lie on the circle, and Q should be something. And let me write small q, and the radius is still 2. Y coordinate does not change. That's the first thing. Now, what is the radius? The radius of the circle, do I have the radius? The point P lie on the circle, yes, it's related to the first part. The radius is 5 units. Now, the radius is 5 units. The center of the circle is how much? Center of the circle is 4 minus 2. Center of the circle is 4 and negative 2. Now, let me just focus on this diagram. Over here, we have P. This is C. That means over here should be Q, right? In other words, C is the center of the circle. C is the midpoint of P and Q. So therefore, what do I have? We have P, which is 1, 2. We have Q, which is Q, comma 2. We have C, which is 4, negative 2. And it so happens that diagram is not realistic. It so happens that this is the midpoint. So 1 plus Q divided by 2 equals to 4. 1 plus Q equals to 4 into 2, which is 8. Therefore, Q comes out to be 7. And we are taking this, we are taking this, we are equating to this. Taking this, equating to this. So we found that Q is this. Therefore, coordinates of Q is how much? That is 7, comma 2. So that is the coordinate of Q. Now I'll also want to have a look. And this is circle. So that's the booklet, the answer booklet. And circular, and it's not circular measure, it's circle equation. So this is circle, and which question is this? I think question number 3. I think it looks like this one. Yeah, that's the one. Let me just paste the whole thing over there. Okay, let me add a page. Now, the very first thing that we have done, that is this one, question number 3, that the center is 4 minus 2, radius 5. Then the equation of the tangent was given. So this is the first one. That is 4 minus 2 and 5. That's all good, all clear. Radius is 5. Then the second one, part B, the equation was given. That was, we proved that. The third one, Q has the same y coordinate. Q is far to the right of C as P. So they have done using symmetry. I have done it using the midpoint formula. And now we are coming to the fourth part. So let's just wait for the fourth part. So now I would be needing the same thing again. That is this copy thing. Now it says the tangents to the circle at P and Q meet at T. That is simultaneous equation. Now we have equation of tangent to the circle at P, that is given. Let me write this thing in red color. This is tangent to the circle at P. I need tangent to the circle at Q. Now here is one strange thing. That is, if I choose a circle like this, and let's say there is P over here, there is Q over here, there is the center of the circle over here, which is C, and the first tangent that I drew in orange, let it go like this, something like this. And then let me make it even more bigger, something like this. Okay, let it cut, doesn't make a difference. Let me draw another tangent that is going like this. Okay. Now the rule is this angle of inclination, if this is theta, then this is also theta. If this has a positive slope, this has a negative slope. That is the rule that we need to apply. Now let me go back, or we can see it over here. The gradient of tangent at P, so this gradient of tangent at P, it has a slope of positive 3 over 4. Therefore, this one, I think I can use this. Gradient of tangent at Q should have a slope of negative 3, 4. It's not negative reciprocal. It's not about perpendicularity. It's about the concept of slope. If lines have same angle with horizontal, then slope is the same. But over here, one of them is positive, the other one is negative, because one is going like this. We can see it for ourselves. This has a positive slope, this has a negative slope. Now what do I need? I need to find this thing. That is, I have the coordinates of Q, which is 7, 2. So I have 7, 2. I have the equation y minus 2 is minus 3/4 x minus 7. 4y minus 8, that is equals to negative 3x plus 21. 4y is equals to negative 3x plus 21 plus 8. Therefore, negative 3x plus 29, that is 4y. This is gradient of tangent at Q. And this gradient 4y is equals to 3x plus 5. 4y is equals to 3x plus 5. That is gradient of tangent at P. So now what do? We solve simultaneously. So this thing should equal this thing. Why? Because they both are equaling to 4y. So 3x plus 5 equals to negative 3x plus 29. 6x is equals to 29 plus 5, which is 34. And divide by 2, That is 3x is equals to 17. Therefore, x is equals to 17 over 3. That is divide by 2. Yeah, 17 over 3. That is 5 whole 2/3. Is that the thing? 21 plus 8. Yeah, 21 plus 8 is 29. Now let me just double check my working. So this is 4 comma 17 over 4. So 17 over 3. Why am I getting 3? Let me just double check. So this is 3x plus 5, and this is multiply it out. 4 into y is 4y. 4 into 2 is 8. Perfect. Negative 3x, and 3 into 7 is 21. Positive. Negative 8 goes on the other side. That's 21 plus 8 is 29. And 4y plus 3x is 29. 4y is equals to negative 3x plus 29. This is all good. So now this goes on the other side. 29 minus 5. I made this mistake. Yeah. So now let me just do this thing. So 29 minus 5 is 24. Therefore, x is equals to 4. That is all good, all clear. And what about the value of y? Y is equals to 24 divided by 6 is 4. 4y is equals to 3x plus 5. That is 3 4 is 12. 12 plus 5 is 17. That is 4y. Y is 17 over 4. So therefore, the coordinate of that point of intersection is 4 comma 17 over 4. And that is all good, all clear. So be very careful with your working. Okay, one small mistake and that part is gone. Now again, have a look at this particular question. Let me drink some water. I'll just pause the recording for a while. I would like you people to try it out first. So now let's look at this question. The question says a circle with center C has this equation. Show that the point is outside of the circle. Let's get started with the first part. So we have this equation, x minus 8 whole square, y minus 4 whole square is equals to 100. Now if I take this point t, which is negative 6 comma 6, and if I plug in this equation, what happens? Negative 6 negative 8 whole square, negative 6 negative 4 whole square, negative 6 negative 8 is negative 14 whole square is 196, negative 6 negative 4, if I'm not making 6 negative 4. Okay, and this is not negative. Let me correct myself. So this is 6 minus 4, that is 2 square, that is 4. Negative 6, negative 8 is 14. It says it's outside the circle, and this comes out to be 200. And this is 100. That means if this answer came out to be 100, the point would be at the center. Because why? The distance from center to this point should be the radius. And if this thing is coming out to be greater than 200, that means this point is outside of the circle. Make sense? The concept of this equation of a circle, the standard form, it arises from this idea that the distance from the center adds up to this thing 100. This is x minus h whole square, y minus k whole square is equals to r square. Basically, it's using the distance formula. So if the point is on the circle, it should be at the circumference. If we plug in and we get something lesser than 100, it should be inside the circle. We are getting greater than 100, it's outside of the circle. That is the concept. That's one way. Let me also illustrate in another way. So part A, alternative format. We know that the center C, that is 8 and 4. So this is 8 and 4. And we know that this point T is negative 6, 6. T is negative 6, 6. That means let me calculate this distance. That is 8 minus 6 the whole thing square. And this is 4 minus 6, the whole thing square. Under root, that is square root of 200, which is 14.142, something like that. We know that the radius is 10. That means the distance of T from center C is greater than 10. That means it lies outside of circle. I think the second one is more explanatory, I would say. So the first one does the purpose, but that kind of seems a little bit short. So I think I'll go with the second method. Let's move to the next part. So part A is done. Now it says the second part, it says two tangents from T are drawn to the circle are drawn. Show that the angle between one of the tangent and CT is exactly 45 degrees. Now that's a good question. Let me first draw a circle. So that is a circle. And the center is 8, 4. So let's say this is 8, 4. That is the center based upon comparing coefficient. The point T is negative 6, 6. So this is 8. This is negative 6. This is 6. Something like over here. So this is T. And then it says two tangents from T to the circle are drawn. Okay. No, T is not. It's outside of the circle, somewhere over here. So this is T. Now, if I draw two tangents, let me draw a blue one and then a green one. So something like this, that is the first tangent. And then there is another tangent that is going like this, a very conceptual question. Now it says, show that the angle between one of the tangent and CT. So where is C? C is the center. And we know that this thing, let me draw it in green color. This is the radius, this is 90 degree. Let me draw in blue color. This is the radius, this is also 90 degree. Now the angle between one of the tangent and CT. So CT and one of the tangent, that comes out to be 45 degrees. That means it's trying to imply this. This is CT and this angle is 45 degrees. So we have to prove this. Either this angle or this angle, they both are 45 degrees. It's just a rough sketch. It's not an exact diagram, it's just a rough sketch. Now, how would you show this? So what we can do is that I can use this concept that I can find the distance CT. So we have the magnitude of CT that was square root of 200. And we have the radius that is 10. Why? Because this is x minus h whole square. This is y minus k whole square is equals to r square. So radius is 10 and 8 comma 4, that is the center of the circle. So let me write root of 200. I can write this thing as 2 into 100 square root. That comes out to be 10 root 2. Keep that in mind. So now this is radius. CT is given. Let me just take this thing out so that I can illustrate it thoroughly. This is the green dotted line, which is the radius, and this is the purple line, which is going like this. Okay, so now I can very well illustrate this. This is T, this is C, this is radius, which is 10, CT, that is 10 root 2, this is theta, this angle is 90, therefore sine of theta is 10 divided by 10 root 2, which is 1 over root 2. Therefore theta is sine inverse of 1 over root 2, which comes out to be 45 degrees or pi by 4. So that is the answer for this part. So this is 45 degrees because we know how to work in the exact form. So that is the question. That is how we would answer this part. So just have a good look at it. And let me also grab the mark scheme for this one, which is question number 7. So this is question 7. Okay. It's outside of the circle. There are two options. Let me first pick this thing up. And the first part, okay, that was the first part. Method 1, that is root 200 is greater than 10, hence outside. And then method 2, that is the distance from this point to this point. Achha, this is like really something different. It's like 2 units more, something like that. So we did this method, that is the alternative format. I calculated the distance CT, that comes out to be 10 root 2, and it's greater than the radius, therefore it's outside of the circle. Now part B, let me just paste it over here. So part B, let me paste it all together. So now just have a look at this. Again, the same concept. That's one thing. And the other thing is the concept of finding isosceles triangle. Because of that, it's 45 degrees. Let me also illustrate it for you. Okay. So now the next method is basically this thing. Alternative method, that is, let me call this point as Q, TQC. TQ is unknown, CQ is 10, CQ is 10, and TC is 10 root 2. Applying Pythagoras theorem, 10 root 2 whole square is equals to 10 square plus TQ square. This is 200, this is 100, this is TQ square. Therefore, TQ square is 100, TQ is 10. Since TQ equals to CQ. Therefore, it's an isosceles right angle triangle. Therefore, there are two 45-degree angles. So that is the thing. Okay, so that is part B. Now it says the third thing, that is the two tangents touch the circle at A and B. Find the equation of line AB. Give your answer in this form. Now, how can I find the equation of A and B? So this one they might have labeled as B. This one they might have labeled as A, or vice versa. Doesn't make a difference. Now they are asking us to find the equation of these two tangents. Now the thing is that if this is again a 90-degree angle, now let me draw it realistically. That is that the two tangents, this is T, this thing is 10, this thing is 10, this is 10, this is 10, and this thing is 10 root 2. This is 45 degrees, this is 45 degrees, this is 45 degrees, this is 45 degrees. That means this thing is like a 90-degree angle. So now if this thing is 90-degree angle, how would we proceed with this? So we have the coordinates of T, we have the coordinates of C. T is negative 6, 6. Let me write everything down. So we have T, that is negative 6, 6. We have the center C, which is 8, 4. We have the radius of the circle, which is 10 units. We have CT magnitude, that is 10 root 2 units. Now, if I want to find the equation of this line AB, I can either use the distance formula, that's one approach, or let me use some kind of trigonometry over here, because I have T, I have B, I have the distance formula. I can use the concept of gradient. Let's see how the examiner has used it. Gradient of CT is negative 1 over 7. Do we have C? Do we have T? So we have this gradient. And then it says attempt to find midpoint M of CT. Equation of AB is this thing. So why are they finding the midpoint of CT? And they are saying that this line should be like this, something like a kite or something. So that is the concept that they're using. Now remember, this length and this length, they are equal. This length and this length are equal. This whole angle is 90. This is 90. This is 90. This is 90. What does it become? It becomes a square. So basically TACB is a square. So first thing, we need to write this down. So TACB becomes a square. It's a parallelogram. We have T. We are going in this direction. So we are going like this. This is like T, this is like A, this is C, this is B. So midpoint of TC should be the same thing as midpoint of AB. So midpoint, we have T, we have C. So TC is a diagonal. Similarly, we have A, we have B, AB is another diagonal. Now let me write T, which is negative 6, 6. Let me write C, which is 8 and 4. Let me write the midpoint, which is negative 6 plus 8 divided by 2, 6 plus 4 divided by 2. That's 2 over 2, which is 1, 10 over 2, which is 5, that is M. Now first of all, what else do I need? Gradient of TC, that is 6 minus 4 over negative 6, negative 8. 6 minus 4 is what? 2. and negative 6, negative 8 is negative 14, which comes out to be negative 1 over 7. Now we know that it's a square and the diagonals are perpendicular to one another. So now this property creeps in very slowly. Therefore, gradient of AB, this comes out to be positive 7 over 1. And now I have this thing. We have the gradient of AB. We have the midpoint, which is 1 comma 5. And I can find equation of AB, and that is what they're asking for. Yes, they're asking for the equation. So that is y minus 5 is equals to 7x minus 1, 7x minus 7 plus 5, this is 7x minus 2, this is y, that is equation of this line. Let's double check. That is y is equals to 7x minus 2. Yes, the concept was a bit tricky, no doubt about that. That's why it was worth 4 marks. And the next one should be simple. Find the x coordinates of A and B. That should be simultaneous equation. Again, I need to copy it. Every single part requires a lot of space with all the explanation at the background. So y is equals to 7x minus 2. Let me write it over here. Y equals to 7x minus 2. And then for this particular part, solve simultaneously with equation of circle, which is given at the top, x minus 8 whole square, y minus 4 whole square is equals to 100. So just plug this thing over here. Y is equals to 7x minus 2. Let me do it on the side. 7x minus 2 minus 4, that is 7x minus 6. 7x minus 6 whole square, that is 49x square. 7 into 6, 42, 84x, actually negative 84x plus 36. So this is 49x squared minus 84x plus 36. And then we have the 100. We have this thing. This is x squared minus 16x plus 64. So now what cancels out? We have 64. We have 36, we have 100, so all these cancel out. And then we have x squared minus 16x, this is 49x squared minus 84x is equals to 0, and x squared 50x squared, and 84 and 16, that is 100x is equals to 0, 50x, x minus 2 equals to 0. Therefore, x is 0, therefore x is 2. When x is 0, y is 7 into 0 minus 2, which is negative 2. When x is 2, y is equals to 7 into 2 minus 2, 14 minus 2 is 12. Therefore, one of the coordinate is 0, negative 2. The other coordinate is 2, comma 12. Let's double check. So where it is, 0 and 2, they're only asking for the x coordinate. So that's how this particular question is done. So I think I'll just stop over here. This is lecture number 1 of circle, and this is part 1 is done. Let's continue with circle in tomorrow's class. Take care.